The inverse of a function is a function that reverses the original function. Once again, this is a concept that sometimes students find hard, and we're dealing with it very, very quickly. So hopefully you can get on top of it. The function and the inverse are actually inverses of each other, so you could interchange the two things. But it's a little bit of notation. There's more notation that goes with this section than I'm perhaps introducing here. If we have an original function called f, the inverse function is called f minus 1. And that's not an index in the usual way, so don't think of that as being 1 over f as you would with an index. It's unfortunate that it's the same notation that's being used to mean something very different. For the original function, this set here is the domain. So remember, these are the x values over here. You then process those x values to get the range, which is the set of y values. If you think about an inverse function, it's got to undo that. So in other words, the set that was the y values over here needs to become the x values. So this set is actually the domain for the inverse function. You then process these values and it maps it back to this original set. So for the inverse function, these are the y values. So there's this interchange between x and y. And we'll see that that's useful in some of the examples below. Okay, suppose f maps x to x squared, and this is a notation that just simply means f of x is x squared, but you need to actually be used to it. Now, it's stated with a domain, x belongs to reals, but if I state that one without a domain, it's implicit that its x belongs to reals. That's called the natural domain of that function. There's no values of that function it can't take, unlike, for example, a square root function where we know it can't take negative values. So can we find an inverse for the function? Well, if we do f of 3, we know that that's 3 squared, which is 9. If we do f of negative 3, that's negative 3 all squared, which is also 9. So an inverse would need to do the following. It would need to take 9 and map it back to both negative 3 and 3. And that means it would fail, think about it on a graph, at 9 we'd have to get 3 and negative 3 and it would fail the vertical line test. So that would be not a function. So the point is that no, we cannot find the inverse for that function. However, you know that there's a square root button on the calculator, and we'll come back to this in a slightly later example. How do we actually produce an inverse for a function with this rule? And it's to do with not having this as the domain, and we'll see that shortly.